Hi mathematicians, this is Mr. Almeida, and we are going to talk about today some basic properties that are involved in mathematics. This property today we're going to focus on is called the distributive property. The distributive property is a really important property that we're going to use in mathematics because it is going to be the kind of glue that connects addition with multiplication. So we're going to talk more specifically about it, but in general, the distributive property is going to be the property that does the combining of multiplication and addition. We've already gone through in our previous videos the properties involved with addition and the properties involved with multiplication. In particular, they're called the commutative and associative laws. But we're going to now use the distributive property that's going to combine the properties for multiplication and addition. So I think we'd start off with a visual example with specific numbers that are going to help us to understand what's going on here. First, if we look at this expression right here, we see that there is the number 3, and then we see this number here that is grouped together. This number is the result of adding, so we call this the sum of 2 and 3. Now, what is going on between this 3 and this number right here, 2 plus 4? Well, there's multiplication going on. We don't have to write the multiplication symbol or the multiplication dot to know that there's multiplication going on here. However, if it does help you to see that, you can put a multiplication dot in between the 3 and the parentheses to let you know that this number 3 is being multiplied by this number in parentheses right here, which is 2 plus 4. So to start off, we want to talk about using some sort of model that's going to help us understand what the distributive property is all about. And because when we go further into mathematics and use the distributive property on fractions, we're going to use an area model for whole numbers as well. So because we're going to have to use them for fractions later on, let's just start off with the same kind of model that we're going to use with whole numbers right now. So we're going to start off with an area model. And we start off with something called the unit square. Area is the number of square units that can fill up a shape without any gaps or overlaps. So this square right here is what we call the unit square. So this will be a length of 1 unit here, and a horizontal length of 1 unit here, and a vertical length of 1 unit here. And 1 times 1 will be equal to 1. That's why this is called the unit square, because this is what 1 square unit will look like. What we're going to do now, because we know this has a horizontal length of 1 unit, is we are going to make a horizontal length of 2 units. We'll make a horizontal length of 2 units, and remember this has a length of 1, so we want to tile this across twice. So this is a length of 2 units, 1, 2 units. And then from this length right here, we're going to continue on for 4 more units. So let's do that. We're going to continue on for 4 more. So 1, 2, 3, and 4. So this right here, as you can see, is a length of 2 units right here. So we'll call this the horizontal length. This will be the horizontal length. There's an O there. So we see a length of 2 units. Just want to show you that this has 2 different parts. and a length of 4 units. So we have a length of 2 units here and a length of 4 units there. Now what does this 3 tell us? This 3 tells us that we're going to have 3 copies of this. Well, to show area, I'm going to now use this number 3 as my vertical length. So this will be how long my vertical length goes, and vertical means up or down. So this will be my vertical length. And so this is going to have a vertical length up and down of 3 units. So right now it's 1 unit long. Two units long. 3 units long. So this is my vertical length right here of 3. Now, this isn't quite yet a rectangle, so what I'm going to do is continue tiling each row with the same number of tiles that are in the first row. So this row will also have 6 square units, or 2 plus 4. And this row will also have the same number of tiles, or square units. And this model right here is slightly imperfect because, as you can see, there are some tiles that are not quite with gaps or overlaps. Okay, so this right here is what we're going to show as the number of square units that can cover this rectangle. So if we look right here, we see our first rectangle that we drew is going to have a vertical length of 3 units. So there's our vertical length of 3 units, and a horizontal length of 2 units. Is our horizontal length of 2 units. And then on a rectangle, opposite sides are the same length. So if this is 3 units, this is 3 units, and then this down here is also 2 units. Now, how many square units are inside of this this rectangle right here? There are 3 times 2 square units, and in here you can see that this is 6. So there are 6 square units here. 3 times 2, or 6 square units. Six square units, and this is the abbreviation for square units. And then this rectangle right here, which I'll draw in a different color, is going to be made up of 3, vertical length of 3, times 4 square units. Times 4, vertical length of 3 times horizontal length of 4, which is 3 times 4 square units, or 12 square units. So if you can see, the distributive property is taking addition right here and showing you how addition and multiplication can be combined. So we have the area of this rectangle right here is equal to 3 times 2 plus the area of this rectangle right here, which is 3 times 4. And as you can see right here, the distributive property is just the glue that lets you know how to combine addition with multiplication when there is multiplication. So what essentially is happening here is we're going to multiply 3 by 2, because 3 times this number right here means we have 3 copies of 2 plus also 3 copies of 4 if we have 3 copies of this entire number right here, which is 2 plus 4. So that's the distributive property. Let's do another example without having to draw the individual tiles. Knowing what we did right here, we're going to apply it to a different number expression. So we have 5 times, again if you need to see it there, let's write it in, times the sum of, this is the result of adding, 4 and 3. So remember, when you have two numbers being multiplied by each other, the result is going to be, this number will be your vertical length, and this number right here will be your horizontal length. So let's draw our vertical length first, and we have a vertical length here of 5 units long. So there's our vertical length of 5 units. And then we have a horizontal length of 4 plus 3 units. Let's just show different coloring so you can see where these numbers are coming from. We'll color this length with green, and we'll color this length with magenta or purple. So the length from here to here is going to be 4 units long. And the length from here to here is going to be 3 units long. And then with a rectangle, we are going to have opposite sides be the exact same length. So if this is 5 units long, if this vertical length is 5 units long, this vertical length is going to be 5 units long. And if this horizontal length is 4 plus 3 units long, this is going to be 4 plus 3 units long. This horizontal length as well. Alright, as you can see, I have a length right here, from here to here, and a length from here to here. So I'm going to partition the other horizontal length, just like that as well. Alright, and then I'll connect the horizontal markings. Now this right here is going to be 4 units long, and this is going to be 3 units long. If you remember before, on the previous page, we were tiling this, so we had 4 units, 4 square units across, and then we had that going down for 5 times. So as you can imagine, the area of a rectangle is going to be 5 times 4 square units. So 5 times 4 is going to equal 20. So we have this being 20 square units. And the area of this rectangle is going to be, again, vertical length times horizontal length, which is 5 times 3. And that number of square units is going to be equal to 15 square units. So the distributive property is going to say that 5 times the sum of 4 and 3 is going to be the same as, so the area of this entire rectangle is going to be the same as taking the area of this rectangle and taking the area of this rectangle and adding them together. So let's take the area of this rectangle, which is 5 times 4 square units, and add it to the area of this rectangle, which is 5 times 3 square units. Now I could also say, instead of saying 5 times 4, I know that 5 times 4 is equal to 20, so I could say this equals 20 square units plus the area of this rectangle, which is 5 times 3, but I know that's also equal to 15, so I could say 15. So 5 times the sum of 4 and 3 is equal to 5 times 4 plus 5 times 3, which is also equal to 20 plus 15. As you can see, this 5, you have 5 copies of 4, which is 20, plus 5 copies of 3, which is 15. Now we take it to one more level, where now I'm using a symbol that's going to represent a whole number, but I don't know specifically what that whole number is. Just know that A represents a whole number. So it could represent any whole number, whether it's 5 or 8 or 10 or 22 or 1. It's any whole number. Okay? So we're going to, again, when you see this expression right here, 3 times this number right here, this will be your horizontal length, and this will be your vertical length. So we have a horizontal length of 3, and that's only one part. And then this, so we have a vertical length of 3, and this horizontal length is going to be broken into 2 parts. One part is going to be A, units long, and the other part is going to be 6 units long. A put together with 6 is a length of A plus 6. So then I finish my rectangle with opposite sides being the same length and also having the same markings. Okay? So I find the area of this rectangle right here. 3 times A. Remember, A is a whole number, so 3 times A would represent, the area would be 3 times A. In math, sometimes we don't put the multiplication dot here. We would just write 3 times A, so you'd see it sometimes written like this, 3A. All right? And so that's the area of this rectangle. That's how many number of square units there are. And then this area of this rectangle will be, again, the vertical length times the horizontal length, which is 3 times 6 square units. Or, let me use the multiplication dot for that, 3 times 6, or 18. So this is equal to 3 times the sum of A plus 6 is equal to the area of this rectangle, which is 3A, plus the area of this rectangle, which is 3 times 6, or 18. Okay? Now, in general, we've gone through 3 different examples. We want to show what the distributive property is for any whole numbers, or any number, as we'll continue on throughout. So the distributive property says, if I'm going to find the area, I'm going to use the area model for the distributive property. The area of a rectangle is found by multiplying the vertical length times the horizontal length. So if I were to show the area of this rectangle here, this entire rectangle, I would say A times the, again, I don't have to put the multiplication dot because I want to be very clear, I will, the horizontal length, which is B plus C. The area of this entire rectangle is going to be the same number of square units that the area of this rectangle is, plus the area of this rectangle. So how do I find the area of this rectangle? I multiply vertical length by horizontal length, which is A times B, and then I add that to the area of this rectangle, which is A. Remember, opposite sides are the same length, so we have A here. This will also be A, so A times C is AC. And that's the distributive property. Now I also want to let you know that if this is the distributive property, if A times the sum of B plus C equals AB plus AC, remember A, B, and C are whole numbers, then when you see this side of the expression, first, you should also know that it's also equal to this side of the expression. Let me give you an example here. Say I have 5 times 3 plus 5 times 4. And let me use multiplication dot here again just to avoid confusion with symbols. So this would equal A, in this case, is 5. So you have 5 times In this case, the b is 3, so b is 3 here, plus 4 is c, and so 4 is c right here. So this expression right here, 5 times 3 plus 5 times 4, is the same as, is going to give you the same value as 5 times the sum of 3 and 4. Because what you're saying is you have 5 copies of both of these numbers, 3 put together with 4. I hope that you gained a lot out of this video. The distributive property is extremely powerful. It doesn't just show up in trying to rewrite expressions in different ways. It actually shows up in many of our algorithms that we use. Most notably the multiplication algorithm that we use when we're multiplying numbers. And it really is used throughout all that we use in mathematics. So knowing the distributive property is going to be really important. And sometimes you might not think that it's important, but after you go through this video and you start to apply it, you'll see that it's very, very important, and you see it in many different places in mathematics, and it shows up in many concepts. So I look forward to you continuing with the videos to help you out, and hope that you enjoyed this video on the distributive property.